I think it's about time to start. We're a little late, but well, that happens sometimes when you try to step out of your comfort zone and try to do something in a different stack than you're used to. That's also part of why I'm giving this talk today. So today we are going to talk about a bit of full stack engineering, and we're going to use Kotlin Multi-Platform for that. Just wondering, who of you has experience with Kotlin? Let's start with Kotlin. I have a lot of experience with Kotlin. I think see some hands here. I'm not really able to see you guys online if you have experience, but I'll assume you have at least some, seeing that you joined this one. Who of you knows about Kotlin Multi-Platform or maybe Multi-Platform Mobile? I see 2 hands, 3 hands, and a bit. All right, so we've got some experience, we've got some less experience. Are you guys generally full stack or like single stack? Who's full stack? Who does both native, front end, back end, at least more than one, let's say. Okay, still seeing some hands, but mostly not really. All right, that's good to know. So let's dive into it for today. And I think in half an hour, maybe 40 minutes, you all know how to actually start programming in Kotlin Multi-Platform. So a little bit about me. I'm an engineer at Flock Community, which is a community of software engineers that are trying to build a better world by trying to make better software each and every day. And I do that for several clients, some of which are very happy to start using Kotlin, some of which aren't so happy about using Kotlin yet. But of course, our goal is to make everybody use Kotlin, not only for backend development, not only for Android, but actually for everything, because I believe that Kotlin Multi-Platform is a nice stepping stone to do that. So that is also what we're going to talk about today. We're going to talk about Kotlin Multi-Platform. It's basically a tool for you that gives you the ability to stop writing code multiple times if you need to an implementation in different platforms. So you have an iOS app and an Android app, and they need to do sort of the same thing. Like you have a web shop and you want to have a good experience, you're probably ending up with 2 code bases that looks sort of similar. What if you could only have a single code base that sort of holds all that common logic and all that stuff, and then actually expose that and start using that as a starting point for your mobile application, making your mobile application way leaner and way smaller in terms of the actual lines of code that you need to implement on that part. Well, let's look at what's available. There are several platforms actually available for which you can start using Kotlin Multi-Platform. And I guess we're going to touch on some of those, but the most important ones are iOS. And actually not only iOS, but everything that's related to OS X. So there's also watchOS, tvOS, that whole chain basically. And it is actually enabled also for the new M1 and M2 chips. Then of course we've got JVM, sort of the thing that Kotlin started with. We've got JS main, so yes, you can actually start exposing stuff to JavaScript and stuff, or actually start using Kotlin JS, which is sort of like a JavaScript type flavor, but then Kotlinified. So you basically get a DSL to start writing your HTML declarative. And then of course we've got the more desktop stuff, which means you can build your native applications. But we'll get to that during this meetup. Of course, if you have questions during the meetup, just raise your hand. I'll try to look behind me so I can see you guys online on the screen. And over here, I have a pretty good view of you. So when should you start using Kotlin Multi-Platform, or when shouldn't you? Well, you could see as a rule of thumb, you could say if there's client-side logic, which you cannot do on the server, but you need to do on multiple different clients on multiple different platforms, say an Android app or an iOS app or a web and maybe a native app or something like that, then it might be a good idea to start using just a single code base for the common code and only do the platform specific stuff on that platform. So it could be a case that you don't have internet, so you can't actually access a server somewhere. Well, then it makes sense, of course, to maybe start using KMP. Maybe if there needs to be something with security stuff related, which you can't really do from a common perspective, but is really platform bound, then of course those are essentially your platform specific controls. So how do you interact with the file system and stuff, that's of course very specific for the platform. And the reuse part is of course an interesting one. even if you don't need like the specifics like internet or secure API, but you do need to share a lot of logic still, it might be beneficial to start looking into Kotlin Multi-Platform. So how do you actually start with a project if you want to do multi-platform? Well, it's Kotlin and Gradle are sort of good friends, and you basically have a plugin that you need to add to your build at Gradle, which says I want to use Kotlin Multi-Platform with a certain version. I'm a little bit behind. And that's basically it. That's somewhere you get a property available which is called Kotlin, and in there you start defining the platforms for which you want to start coding. But it's in essence it's nothing more than this. This basically gives you access to all those different platforms that we just saw. Of course, I want to make it a little more appealing to you. So the question is, what is it that we're actually going to implement now? And funny thing is, I actually found a small company called Garble, which has some problems, and they want to have a solution which could potentially be multi-platform. Yes, this is fictional. So it's Garble. This is their head office. It's a company that does things, and it's led by a guy named Jack. This is Jack. Say hi to Jack. So Jack has a use case for me and says, hey, Julius, I need to generate passwords every now and then for company accounts or maybe apps we actually generate with our company in there and all these different platforms, right? We've got Ivy that's coming up with her iPhone. We've got Peter that's coming by saying, hi, I still work on a DOS machine. Can we do something for that? We've got some Linux geeks over here. So how can we do something that, you know, once and for all we get a password generator that works for everybody? Can you do that? Well, I'm not sure if I can do that, but at least I can try, right? So let's start with defining a function, because what we want to do is we want to generate a password. So that's going to be our use case, how to generate a password. And well, that question is the same for all platforms. Give me a password. But of course, we could just start with a very naive implementation, saying, give me a password, I give you a length, I say there are a couple of characters you can use, so everything from A to Z in capital, everything from A to Z in lowercase, and then we just repeat that we say from the random class from Kotlin, get the next integer given the size of my character pool essentially, and keep adding that to my password. And then you return that, and then there's an example on the bottom. If you call it give me a password with argument 10, then it returns just some random string. A pass garble, you might call it. Of course, the question now arises, what is actually wrong with this? And the most important one is typically you shouldn't be doing your own cryptography. There are guys that have studied years and years for this, and typically you should piggyback on what others have thought is a good idea to do cryptography. Second of all, please don't do your own cryptography. So if you really want to do it, keep paying attention, but this might not be the best example you want to try in real world, or you should not be using it for very serious applications. So if you think you're going to go into crypto and you're going to use this, don't even think about it. But if it's like, I don't know, you want to make sure your printer is safe or something, this should still be usable. The problem with this particular thing, if we're going to dive into it, is that the random class in Kotlin is not really that secure. It only has a variation of, I think, 32 bits, which in cryptography world is not that much and actually get you into trouble. So the variation that you actually can get in terms of different passwords isn't that big. And of course, more from a user perspective, it's rather limited in terms of how you can use this, right? You can only use uppercase and lowercase. You can't even decide which ones to use. How about those numbers or special characters, all those kind of things? Okay, sure. Knowing that, we're going to rework the function a little bit, and then actually we're going to see where we need to find a hook to the platforms, because of course we need to do some platform-specific work here as well. So we're going to focus on getting a random character from that character pool. So we have a character pool with essentially a list of characters, and we basically say from that character pool, get a character at a certain index, and that index is determined by actually getting a random int based on the garble, or actually the size of the character pool. Then we already start to get into a little more complicated stuff. I'm not going to go into detail, but essentially what this is doing, it's saying I want to get a secure random byte from somewhere, and I want to do that until I make sure that the byte that I get back is sort of nicely distributed over the range that I'm requesting it for. We could go into detail about this, but that's not the point I'm trying to make during this presentation. We can come back to this in the questionnaire at the end. So the focus that I want to put on here is the get secure random bytes, because that is where we can benefit from the platforms that we're going to implement this on. And when I say benefit from the thing that we're going to go to platforms, is where we're going to use an expect keyword. So I've created a function, that function called get secure random bytes, and I put a little keyword in front of it called expect. And actually what that expect thing does, it is provide a hook to platform-specific functionality. So there's actually not an implementation of this one, because it's an expect function, but Kotlin expects me to provide an actual function. So actually they come in pairs. Well, not necessarily in pairs, they come in they're sort of bound together. So if you have an expect one for every platform that you're going to implement, you also need an actual function. So basically an implementation to your interface, you could say, but it expects that one, and that way you can actually benefit from the functionality of the platform. Let's take a very simple example. Here's an overview of how this should work. So in the common source set, and we're going to see that in a bit, the common source set, I expect a certain function or expect a certain class to be present, but I can define its interface. And then in the implementation, in this case an iOS or an Android, I actually define what that function is, or I give the actual implementation of that function, both for Android and iOS. And of course the benefit is in iOS I can use the native libraries that are supported by iOS, and in Android I can use the native, or not native, I can use the JVM libraries, because Android is JVM based. A very maybe trivial example is a logger. Maybe you want to provide logging functionality to each and every one of your platforms for the common stuff that they're doing with you. So I expect a log message function to be implemented, and then I have the ability within the common platform myself, or the common part myself, to actually write those log messages using the write log message function that will be implemented by the different platforms. And here are two examples. So for JVM, for example, we just used the simple print line function from Kotlin, but it's actually bound to a JVM thing. And maybe for JS, we say we want to use the console logger from either the browser or the Node V8 engine. That makes sense? All right, see some nodding. All right, so we actually got our first customer. His name is Jonathan Van Moor. Maybe you recognize him from Garble somewhere if you've been around, maybe not. And he's asking me, can you give me a library to actually generate passwords? Because I need it for this Garble app that I'm working on to generate passwords for whenever a new user is actually creating an account. And I want to give them like a secure password when they start, blah, 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 that whole thing. Well, funnily, I know that Jonathan Van Moor has the initials JVM, and so I can assume that he's actually doing something with either Android or Java or whatever. So we're going to go on that assumption and say, okay, let's start implementing a JVM library. So now we're going back to our build Gradle file, and what we're going to do is we're going to say in the Kotlin thingy, hey, we want to do something with JVM. Okay, sure, we're going to do something with JVM. We're going to say that we need to target JRE11. This is a target, JRE11. And we're going to use JUnit to actually test things. This is normally how you would describe a JVM-based application or a library in any Gradle part, actually, except, of course, for the JVM bounding around it. And then we have the source sets. We already started with the common main and the common test source head, in which we did like the function that we just described, and now I'm actually adding the JVM main and the JVM test, which is allowing me to also add dependencies and stuff. I'll show you in a bit what it looks like. So we've got a source, and in that source we have the common main and the common test, and now we're actually adding the JVM main and the JVM test. All right, so what is it that we actually need to do? Well, we actually only need to implement one function, because it's only that get secure random byte function that we actually need to implement, because this is the only expect function that we've had. So it says, okay, get me some random secure bytes of a certain length, and reply that to me. So what I can do, I can import something from Java Security Secure Random, which is nice, which is of course not available in the common source set because it's a Java JVM specific thing, but it is available for me. I say, sure, give me an instance of that secure random thing, and then whenever that function is actually being called, I use that to generate new bytes. So basically I set up a byte array, and I fill that byte array with random bytes, and I return that string or that byte array of bytes. And actually, that is all that we need for a library in JVM as an addition to what I've written in my common thing. So it's just basically a one-liner, or 2 or 3 liners. Let's make Jonathan a little more happy and actually see how we would apply that. So we're skipping a little ahead because this is JavaScript and we're not interested in JavaScript, but we're interested in JVM related stuff. Is this big enough, by the way, for you guys? Is this visible? Okay. All right, great. So I said we already had a common main, and in common main I basically have my common password generator, in which I have a single class which is called the common password generator, in which I define something like character classes that I want to probably use, and I essentially have a generate function, and in the generate function I actually start generating that thing. So I do some validation to make sure that you actually are requesting characters from from a character pool that is larger than 0. Then I actually start defining how big that character pool is, and then basically from 1 till the password length I start retrieving a random character from that character pool, and this is where the magic happens. This is where we say go into that get random int thing, which actually drills down to get secure random bytes, which shows me here on the left that there's just a single the file with a single function in it that actually is trying to get that thing. So if we look how that works, we go into the JVM main, and there we see that implementation that I just showed you, right? So in my JVM main source set, I only have a single file, and that is it. And because I extended my build Gradle file, let's see if we can easily get there. Yes. So I basically put in something related to JVM. I am now able to actually build this. So whenever I hit build, I will actually end up with a JVM, binary, so to say, that I can start using. But of course, it would be nice to actually make an example. So I have a small example in which I'm actually, is this working? Oh, this is actually working. That's nice for once. In which I'm actually gonna show a small CLI application built with Pico CLI. Maybe sounds familiar, maybe not. And then actually using GraalVM to actually turn it into a native image as well. The native image part is of course not really necessary because I can use Kotlin Multi-Platform to turn something into native, but it's a nice exercise to do regardless. And maybe we'll see in a bit why that is. So I started here doing an implementation. It's PassGarble, it's a CLI specifically for the JVM. And without getting into too much detail of how Pico CLI works, it essentially gives you the ability to specify what options there are. So if I build this to an application called PassGarble, I can then with the command line say PassGarble, but also use the flag -l or -length to indicate, well in this case, the length of the password, or whether or not I want to use uppercase characters in there. yada yada yada. And then there's one interesting thing is at some point in time I do need to generate a password, and then I just say common password generator.generate, use the properties that I specified, and then give it back to me. I do use run blocking. That might not be the neatest thing to do, but regardless, it actually works. Which means that I should be able to show it to you. There we go. That if I go into examples, something with JVM. No? Wait, I should go into PostGarble first, of course. Yes, there we go. Example, something with JVM. There we go. I already built it, and now I can actually execute it. So I just need to say something that's like ./app. There we go. So I'm going to say execute this one with a length of 10, no uppercase and no special characters, and then it actually fails. That kind of sucks. All right. I guess that's the demo effect. But of course we can just simply build it, and then it should work again. Dum, 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 dum. Just bear with me. Do, do, do. Do, do, do. Do, do, do. Come on. Why are you taking such a long time? Could probably be because of Graal, although he's not very working on Graal, but Graal is doing quite a lot of stuff to compress a whole JVM into a tiny little executable and try to take away everything you don't really need. So actually end up with an executable which is relatively small, but actually includes a JVM in itself. So I should be able to run it now. No, I'm not. That kind of sucks. That was not what I was expecting. Let me quickly check on the README. I actually wrote a README for this one because I need to build a native image. Okay. So actually, that's going to compress my whole JDK or JRE into 20 megabytes or something, which is well, considerably smaller than what you would normally expect, which is around 500 MB or something for such a thing. Okay, you know what? We're going to come back to this one because this is probably going to load for a bit. So during the next demo, I'll start with this one. All right, there's a demo backup. Ah, nice. This is what the output would actually look like. So it's of Graal. So this is what Graal is doing. This is not necessarily a presentation about Graal, but Graal is trying to compress everything together and make it as small as possible. In my case, I basically end up with an executable of 20 megabytes, which is still quite considerable for seeing that I'm only needing to use some random bytes, or trying to get some random bytes. And then this is the output basically when you request 100 different characters. Supposedly this is secure random. All right, we've got another one. Hey there, I'm Nadia Vedder. Nadia Vedder, all right. I'd love me some passwords on my Apple devices. Help me out, please. I want a very simple library that can use for both CLI, iOS, and OS X. All right, let's see if we can do that for you, Nadia. Let's see how far we can get. There you go. Okay, so now actually we need to add a native library. So simply, indeed, we need to add a native source set, which we define in this way. So we say for Mac OS X 64, we want to have a source set with the name called native. So it's basically an alias for that one. And then we want to give it a bundle ID because that's easy. And we want to use a binary with a framework, giving it a base name. And that should be about it. And then whenever you start building this, it actually gives you a C interrupt, or actually a C library that you can use in OS X and everything within OS X, which is pretty nice. But of course, we're going to need an actual function again. So how are we going to get those secure random bytes? Again, here was the common thing, and this is actually how you get a secure random byte in OS X. So it's already starting to get a little bit more complicated. You basically try to do something, but you don't really know if it's successful, so you actually need to check out whether it was successful, and then when you get it, you can actually return it. So that the sec random copy bytes is actually just the response code, not necessarily the bytes that you put into your byte array, because the bytes pointer is actually what you start filling. That takes some time actually figuring out how that actually works, but the good thing is you only need to do it once, and you only need to do this thing because all the rest was taken care of, right? Thinking about how many characters you want to have, if you want to have uppercase or lowercase, that's all part of the common part and not part of the thing that you actually need to implement in your specific platform. Then what you could do as well is actually start using Cocoapods. Not sure if that rings a bell with some of you who have developed on iOS or Mac OS. Yeah, anything Mac related essentially. Not really. It's basically NPM for Mac or Mac OS, OS X kind of thing. So you can basically define a pod file in which you describe how your library looks like, and of course you basically attach a binary, and then you can start using it like you normally would. You can also declare dependencies that you actually have on other pods and stuff. So yeah, I'd say it's pretty comparable to the NPM kind of thing and the packages that you find there, but then for iOS OS X. We need to define a couple of things here: the version, the summary, and a homepage. A name is always nice to have, and then the deployment target is also good to have, because otherwise it might not be compatible with whatever you want to use it in, because Cocoapods uses a spec file together with the pod file that you can actually need to use in Xcode. And then we give two properties so we can help actually build both the debug version of the application that's implementing this one and the release version of the application that's actually implementing or consuming this library. So let's try to make Natalie happy and see if we can give her a demo. I know that we can give a partial demo for sure, but let's see if we go slightly back to the JVM example. It still doesn't work. All right, I'll try to fix that for next time. But for now, this is the demo effect, unfortunately. All right, let's go to the implementation that we have for Nadia. Not this one. We need this one. So for Nadia, what I was hoping to do was actually create both a CLI tool, which is then native, and a Mac OS application. Unfortunately, I haven't been able to get the Mac OS application running today. It was running before today because apparently, well, when you give a demo, things start falling apart. But it would definitely be able to start showing you the native CLI application. And the cool thing is I actually used Kotlin native for this. So Kotlin also allows you to start, well, programming in native and actually giving you an executable that is natively, well, native to your platform, essentially. So what I need to do is I have written a small app, which is relatively simple. It's going to print the help of how you should be using the application, which is always nice. Then it's going to say, okay, I'm going to need an instance of this pass garble thing, okay, whatever that is. That's probably my password generator then. And then until the end of time, I will basically take the next user input to determine what to show the user. Typically a lot of passwords. All right, so what is pass garble? That is something that comes from my build application. It's not the thing that I wanted to show. The thing that I wanted to show you guys was in my official thing, the native main, that I wrote a small thing called pass garble here because I had some trouble reaching the common password generator, which was sort of which is nicely tucked away in a package, but I wasn't really being able to communicate with that packaged nicely when I exported it as a native image and tried to use that both in macOS and somewhere else. So what I did is I basically made actually sort of a delegate thing that is essentially the same thing but then on root level without any packages beneath it, and that's the thing that I'm also calling here, but it's not doing anything different from the underlying thing. If you have thoughts on how to fix that, I'm more than happy with your feedback. All right, let's read the README this time. I need to do a build. Ooh, can I do that from here? That's awesome. All right. Of course, this is gonna take a little bit of time, and I'm expecting it to be a lot less long. See, it's already more or less done. And then I should be able to execute it here. So I'm going into the native CLI, yes. And then in a little bit, whenever that thing is done, I should be able to run it. Native test is still running. All right, there we go. Shady thing is I haven't defined any tests. It's still trying to figure out for 40 seconds which tests to run, which is, well, not the smartest thing. But we're getting there. We're getting there. Ding, ding, ding. Okay, let's see if I still had something on my class path available or my build path. Yes, I did. Okay, cool. All right. So here we have a slightly more interactive CLI, which is actually describing what's going on and then actually giving you a lot of passwords. So I can just keep on requesting passwords. But for example, I can type the word health or length to then set a new password length. So if I say I want to have 100 characters, then you should be going away. There you go. This can be hidden. Then you actually see that, that the passwords are a lot longer. And the cool thing is I can also say don't include upper characters, don't include lower characters, don't include numbers, and if I add don't include special characters as well, then you have no characters to pick from, so actually the application crashes. So you can even see that when you crash you actually get references to, I think these are pointers to a position on memory. It looks like it with a little bit of reference to it, but it's quite nice to see that even exception handling works, and if you don't catch anything it still bubbles up in your application, basically starts falling apart. So that was a cool find. So yeah, Nadia, or Natalie, wasn't it Nadia? I thought it was Nadia. Yeah, so you'll have to excuse me for not providing an OS X demo. I still have it somewhere on my machine, but it's not working. I'll get back to her next time, but let's see who else is there. And we've got Andy Roy Ingram, which is a weird name, but Andy Roy Ingram is a guy, I guess, which is a mobile app developer. Andy Roy, yes, check. I am a mobile app developer and I need help with a password generator. Can you please help me out? Come on, help me out. Okay, yeah, sure. Garble offers some apps with password generation capabilities. Alright, it's not the longest description I ever had for a task, but sure, it's something with a mobile app developer, blah, blah, blah. And he's called Andy Roy, so let's just stick with Android for now. And that's actually pretty cool, or easy, because we can take a shortcut. Because we all know that Android actually runs on JVM. And we already had an implementation for JVM, which is quite awesome, so we can actually reuse the JVM lib that we built. Okay, let's make Andy happy. Yeah, it was called Andy. Let's make him happy and see if we can start up Android Studio. So in Android Studio, I can start a device, an emulator basically, and I've created a very small app, and I'm by far not the best Android developer. Well, haven't written this. I'm pretty sure I'm not an Android developer, so I probably need some help from the community to actually get this into a proper app. But essentially what I do is two things. Let's start with the view. That makes, I guess, the most sense. I essentially just created a very simple view in which there is like a table in the middle. Sort of try to use Material UI here, in which you can select the length and include the classes of characters that you want to use, and then actually generate a password. And then the idea is that the thing on the bottom will actually give you your password, and then at some point in time you should be able to copy that so you can use it in whatever you're doing, another app, or maybe on web, or whatever it is that you're doing on your Android device. But the issue that I was running into was, okay, so I need to react to someone clicking on a button. Sure, that makes sense. So I can say the generate password action, which is sort of the binding that I've given. Set on click listener, and then you should do something. So someone clicked on the fact that he wants a password, then I should do something. Sure, I can check what the value is of all the checkboxes that are set in the thing. That works. I can even log it if I want. But then of course I need to generate that password, and I didn't really know how to work with coroutines here, so I went with a big boo-boo and said, okay, just gonna go run blocking. That works, right? Run blocking works. It's not what you should be doing, but it works. So once again, if you're an Android developer and you start crying because of this, reach out and let's try to make this a little bit better. But the cool thing is, if we look over here, then on the right, we actually have a working implementation. So even when I click here, it says how many things do you want to have? Well, maybe I want to have 25, something like that. And then I say generate a password, and then you see over here it's a password. If I exclude special characters, you see over here that it doesn't include special characters. I know it's a little bit small, but there are no special characters. If I only want to have lowercase, then it's only going to be lowercase. Well, you sort of get the gist. So it works, and I, well, could call myself a full-stack developer. I know a little bit of Android, but no, I'd rather do this together with someone who actually knows Android and tell them a little bit more about the benefits from Kotlin Multi-Platform. So anyway, what we're doing is trying to engage in conversation, right? That's what we're trying to do as a community of software developers. Anyway, I think Andy was happy, and we can sort of skip through the demo backup because, well, we don't need it. And now we've got a wavy girl. It's called Javelin Scripture here. Okay, hi Javelin. On the www interfacing platform, I am in desperate need for a password! Exclamation mark. All right, I use a lot of different frameworks, Angular, Stencil, jQuery. Can you make something that works for all? Question mark. Well, I don't see why not, so let's give it a shot. What is it that we actually need? All right, so we're probably gonna need a JavaScript library. Javelin. Oh, okay, this is a very bad one. Never mind. A JavaScript library. So what we're gonna do is we're gonna add another source set, the JS main and the JS test one, and we're gonna say we're gonna use something with JavaScript. We're gonna use IR, which is one of the two compilers that you can use to generate something with JavaScript. And we're going to say that Webpack, which sort of comes along with Kotlin JS and the whole framework, is Webpack. And we need to say to either build in production mode or in development mode, like you would normally with Webpack. And the IR thing, it basically says that there's sort of an intermediate layer that Kotlin uses to compile to, and from there actually do the rest of the compilation. The benefit of that thing is that they're way better in tree shaking and dead code elimination, basically allowing you to have a way smaller bundle size, which on web is typically what you really want to have. All right. Again, we need to implement an actual function because we're on a different platform. It's related to JavaScript stuff, and there's once again this function that we need to have an actual function for. So how are we going to get secure random bytes on a JavaScript or a JS ecosystem? And we basically have to deal with two here, right? Because we both have the stuff that's happening in browsers, and we have the Node ecosystem, which we need to take care of. Luckily, I'm not the first one who's trying to do this, and someone tried to make a library that has something to do with cryptography and try to make it actually multi-platform so you could actually use it in several different places. And the multi-platform specific part is more for web than other things, but it's something called Libsodium. Maybe the web guys over here have heard of that one before, but it essentially allows you to get secure random bytes in a web or Node.js environment. So essentially what we need to do is whenever it's not initialized, initialize it, and then just say there's a buffer of bytes, and we need to fill that bytes. We need to fill that buffer with new bytes, and then actually return that byte array. That's actually about it. And then of course, well, you might think you're there, but of course we need some magic because we've written everything in Kotlin. This is actually just a Kotlin function that I've written, but we need to export that to JavaScript because Javelin wants to use that in an ecosystem which is only JavaScript supported. So no Kotlin, nothing like that. So can we do that? Well, yes, we can. Otherwise I wouldn't be here. But we can add some magic to export my Kotlin stuff into a plain JavaScript library. And how can we do that? We can use certain flags or annotations. We can set an annotation on either classes or functions saying I explicitly want to export this thing with this name to be reachable whenever compiled to JavaScript. So whenever compiled to JavaScript, there is going to be a class with the name password generator within the module that I've defined that I can actually use like I normally would be using a JavaScript or a TypeScript class. That's pretty cool. Okay, we also have JS name, and here's an example why that could be valuable. In JVM or Kotlin and other languages, you have the ability to use, God, what's the term again? Have the same function but with different lengths of argument. Is it function overloading? It's called function overloading, right? Thank you. Function overloading, you have that. It's not something that you have in the JavaScript world. So to make that possible, you actually need to give them unique names. You can either do that by actually giving them unique names, or by using this annotation saying I want to use a different name in the JS world than I would in the Kotlin world, which in some cases makes sense if you want to use this internally in your Kotlin JS part as well. Then maybe at some point you want to call it with just one argument, at some point with two arguments. And I think underwater it will always, it will not necessarily keep the name intact unless you've explicitly set it to export. So it can basically do with it whatever it wants, because if I wouldn't be exporting these two functions, if it would be JavaScript, then there would still be a collision between those two functions, I think. I'm not sure if JavaScript is able to deal with function overloading at all. Again, this is sort of where I lack the full stack thing. I know about a lot of concepts, but well, I'm lacking on this part again. But anyway, this is how we define it. So let's see if we can consume it. So I made a very, very small, not really trying to use much libraries or frameworks. Try to see if I can make a form in which I can actually try to request a password. And this is what it looks like. So whenever I say that I want to generate a password, then at some point I should actually get the options for that password, right? I should know the length and those kind of things. So there's a function, get the password options, which is basically from a form trying to get the password length, trying to get to include lowercase thingy, the uppercase, blah, 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 all those kind of things, and then actually creating a class, a small data class, in which I need to provide all those options. For now I've chosen for a class, but maybe in the JavaScript world an object might make more sense because that's easily extensible, so it's overridable, and that's of course not really the case for a class is, but a data class in Kotlin is, well, difficulties. All right, so let's see if we can make Javelin happy and give her an example of how it actually looks like in JavaScript, and then we'll start rounding up. All right, so where do I have it? I think I have it over here. And so this was that one. I have a couple of examples. There you go. Plus Garbo.js. There we go. Again, I also wrote a small README, so I know what to do. So I need to do an npm install, and then I need to do a npm start. All right, I think I can do that somehow. So, oh, let's go back. Does that work? There actually was. Alright, so I need to do an npm install. I can do that. I can do that. So the trick that I did before is that I actually published this JavaScript thing to the internet. Well, yeah, I actually published it to the internet, and I'm basically reusing that package. So actually this thing is in the npm registry as a normal npm thing like you normally would. So if you wouldn't know anything about Kotlin, you could still be actually using this. And I can even show you that even the TypeScript definitions are there, so you actually know what you need to provide in that option sync and how you need to get a password. So npm start was the next one. Try to make it sensible. Then blah 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 is building. I'm using Parcel to build it. Not sure if there are any fans of Parcel out here. I see a lot of cheers. Nice, awesome. Thanks for the support. But when you go to localhost 1234, we actually have an application. And because I am sort of a full stack developer and I know how to style things on the web, this looks a little bit nicer than the other ones. So it means I can actually say here I want to do something with the length. I don't necessarily need to click the checkbox, but I can click wherever I basically want to click. And then whenever I say generate password, it generates me a password which is more or less complex depending on the settings that I choose. And I have a copy functionality, so now whenever I go to my address bar, I can paste it in there and then share with the world how such a wonderful password it is that I'm using, which is of course not something that you should be doing. That was a joke. Getting back to the demo and seeing if Javelin is happy. I think she is. I haven't heard her complain, at least. All right, so it's Jack again, and he's asking me how are things with passwords and password garble. How are you doing? Is there do you have any conclusions for me? Well, sure I have some conclusions. I think I can do that. So first of all, once again, doing your own cryptography is pretty hard to get right. Think twice about doing things like this. The thing that I did doesn't seem very harmful if you use it for simple applications and not that much complexity. Second thing is Kotlin proves to be quite flexible to be used as a starting point for many platforms. So you can easily start doing common things like generating a password or thinking about the sum of 1 plus 1, or maybe coming up with a shared model that you want to use in different platforms. That we all know what a password is. Well, password is simple, but if we start talking about an office space that in the context of Garble means something different than it means in the FedEx world or something like that. You can use the power of the platform for specific non-generic parts of your app, meaning that when you need to get that secure random byte, you can actually use the power of the app. When you need to get that file from this, you can actually use the power of your platform. Like if you want to be able to upload forms, for example, maybe you do something with finances and you want people to be able to upload stuff, then this could be a good starting point. And the only hook that you need to implement is how to actually get that file from this or something, or maybe there should be a pop-up on web, something like that. But then the only thing that you still need to do, platform specific. And that's where the expect actual comes into place. Now, Kotlin Multi-Platform doesn't make you a full stacker overnight. I'm not going to claim that I know how to do Android parallel or iOS. I mean, I wasn't able to get the macOS thing running today, so that also means that, well, I'm not the best full stacker, but to do it right, you probably need a lot more interaction between engineers of different platforms. So you probably need to speak up to your iOS engineer and your Android engineer. But is it actually a bad thing? Because typically what we see in organizations is that business talks about a lot of things, and then they say, yeah, we want to have a web application and a desktop application, and maybe even a mobile application, maybe both for Android and iOS. Maybe it's a good idea to actually get your engineers to come together to come up with a common model to consider. And maybe there are a lot of commonalities which you can abstract away from a lot of the platforms by actually doing that in a Kotlin Multi-Platform library instead. Now, what are the next steps? Of course, there's a lot more to explore. I haven't really dove into iOS specific stuff, or Windows maybe There are some Android specific things outside of the specifics from the JVM that I can consume. And what are the layers that we can start sharing? Maybe there's something on a networking level as well. Maybe it makes sense that if you have an open API spec, that you start creating a Kotlin Multi-Platform library in which you do actually an implementation on multiple platforms, and you only need to provide your networking agent, so your fetch API, or maybe it's what's typical for Android, OK HTTP client. It's a little bit deprecated, but something like that, or a Netty client on JVM. And so you don't have to think about network connectivity, but you only have to think about consuming that function. Maybe shared labels is a thing, like label click here to generate a password. I don't think that needs to be different in different platforms, so maybe we should think about sharing those. Assets, icons, pictures, maybe something with typography or those kind of things. Not sure if that will work over different platforms, but it's something that I wanna explore. And with that, there is a big thanks from all of us here at Garble, everyone, including Javelin and Jack and Andy. Any questions?
Can you use structs or shoot traits or aggregate data types between that functions, or usabilities of functions? Or is the only thing
You can actually use more complex structures as an input, in the sense that what you need to provide is an actual implementation to an expect function. That expect function could say, I want you to give me this object that I called common password options, which is a data class essentially, which has typically a length is 31, typically uppercase is something you want, those kind of things. And you can actually say that in the actual implementation you need to use or provide me that object, because you're still extending on the base Kotlin multi-platform thing, which is defining that object. So you can use that. And a struct, I think that term is specific to either Scala or C, I think. C.
Yeah, wondering how it translates with this different pattern.
To be honest, I'm not 100% sure, but I'd love to talk about that during drinks. Correct? Yeah. Okay. Cool. Any other questions? Maybe from the audience that's online?
So we want to comment as JVM, JS, so fun.
Fair enough. All right, then I think we're gonna leave it at that. I was Julius. I was happy to be here as a speaker. I'm not a real full stacker. I just tried to imitate it by using Kotlin Multi-Platform. But Kotlin Multi-Platform is actually allowing me to, well, do a lot more than I expected when I started. So thank you guys for being here, and hope to see you during one of the next meetups. Take care.